All right, hello everybody. We're going to go over conversion of AC voltages and current values. For my example, I'm only going to be using voltage. E is electromotive force measured in volts. So in this case, every place I have E, it means we're talking about volts. So when we're dealing with AC, we're dealing with a sinusoidal wave. It has a peak and another peak. It's not a valley, it's a peak. Peak to peak. This is a cycle, and cycles per second determines the frequency. And the frequency when we do it is measured in hertz. And I did not write that on the board yet. Let me see. So frequency is measured in hertz. HD is the abbreviation. When we talk about AC, we have to talk about that. In the US, frequency is 60 hertz, which will come into play later on when we get further into AC. We're calculating inductive reactance, capacitive reactance. So for this, in this one, we have a peak. You have average, RMS. RMS is root mean square. Also gets called effective value or effective, depending on what kind of textbook or what kind of reference manual you're looking at. Average is also sometimes referred to as mean value, as the mean, depending on the textbook or training or reference manual you're looking at. Peak to peak is a measurement from this peak to this peak. So if we're going to find peak to peak, it's 2 times one of the peaks, just 2 times peak. So when we're converting peak to average, we take the peak voltage and multiply it by 0.637. When we're converting peak to RMS, we use peak voltage times 0.707. If we're converting average to peak, we're using the average times 1.57. If we're converting average to RMS, we're using the average times 1.11. And if we're converting RMS to peak, we use 1.414. If we're converting RMS to average, we go by 0.9. Take a look at something real quick. That's why I actually made a mistake on my drawing, which I'll fix now. RMS is larger than average. So it's peak, RMS, average. Peak, RMS, average. So that's all the multiplication. Here's the definitions of terms and the other meanings they may have. So when we're dealing with, if I tell you, get rid of my little drawing here. So on your typical meter, when you read 110 volts, that is RMS. If your meter says it's an RMS meter, it's going to give you 110 volts RMS. If we want the average, so if we're going to convert from average, RMS to average, we'll multiply the 110 times 0.9, which will give us, we'll move this way, and then it'll give us 99. If we want it to be peak, so we have the 110 volts RMS, and we're going to change it to peak, so it's going to be 110 times 1.414, We'll move this over. Move this back. Because it's easier for me to work with if I knock out that 0. Times 11. Now, somebody make sure you check my math. Henry, that's your job. 155.54 volts peak. The reason I mentioned Henry is because he got me on another one of my videos where I made an error, and I appreciate it. I do appreciate people putting in comments if I make a mistake or they think I made a mistake. I'm good with that. I'll go back and check my work. Henry was definitely right. So here's your peak voltage in this case and your average voltage. Now, if I want peak to peak, all I'm going to do, I want voltage, or we'll stick with E in this case. I flip back and forth because I understand it. But for the sake of learning it, we'll just stick with E for now. Peak to peak is 155.54 times 2. $311.08 volts. Because it's peak, it's voltage, voltage peak times 2. Gives you peak to peak. For anybody who's taking one of my classes, this is definitely going to be on a test. If you're in my AC class, it'll be on your first test, and this can be for years. This is usually the first thing I test. I will do something along the lines of, because by now you should have already had some type of DC course, and you should be able to operate with series, parallel, and the combination circuits. Combination circuit is a series parallel circuit is what it's called in a lot of books. I call it a combination circuit because I hate saying both those words all the time because it gets confusing to me. And I like to keep things as simple as possible. And yes, I know I'm talking to the board. All right, R1, R2, R3. Star Wars jokes are always appreciated. So we're gonna say R1. We're gonna go with 3 ohms. We're gonna go 5 ohms, 20 ohms. No, we're gonna go with. We're gonna make this R1's gonna be 7 ohms. And we'll start with 120 volts. Oh, we'll say average. So if I start with 120 volts average, and in here you can do this with current. It could be I peak, I average, I RMS, same multipliers. So if we solve for this, first thing we're gonna find is current average. So since this is a combination circuit, we have to use both the rules of a series circuit and the rules of a parallel circuit in what we're talking about. So when I go to attack a problem like this, I'll take care of this branch first. It's a parallel branch. And since I'm going to use what's it called? Product over sum is what somebody told me. I just call it shortcut. So 20 times 5 over 20 plus 5, because this can be done this way, is 100 over And we're going to change this to 110. I make this mistake constantly. All right, 25 is going to give us 4 ohms. And since it is a parallel branch, the total resistance will be less than the smallest resistance in the branch, in the parallel. So 4 ohms is less. We meet that rule of thumb. And because now, once we've done this, we've changed the circuit to a series circuit total. So R1 is in series with R2 parallel 3. We just add those up. So our resistance total is going to be 11 ohms. Using Ohm's law, I equals E over R. We get this to be 10 amps for I average. For that, we know that I average at the first resistor is going to be 10 amps. We know here, with the parallel with both these combined, it's going to be 10 amps for average. Sorry, 10 amps I average. 10 amps I average. All right. So with this, I multiply my 10 amps times my 4 ohms. It's going to give me 40 volts. When I multiply these two together, it's going to give me 70 volts for E average. E average. So this is going to be 40 volts. E average, 40 volts. E average, because in a parallel voltage is constant. So then we do the division. This is 8 amps. And when we're doing this, you got to make sure you keep track of what you're doing. You want to make sure if you're doing everything in average, you keep labeling average. Because when I ask a question later, I'm going to ask conversions to RMS, to peak to peak. So you want to keep track of, you want to keep your designations correct. Make it easier on yourself. 2 amps, I average. And I'm sloppy when I do my work. That's why a lot of times I'll just make the table. And fill everything in there. Because if I work around the horn like this, I might do scribbles all over the place. This seems to be a little easier on everybody when they're doing it to organize their thoughts, organize their math, put their answers in. Because what I'll end up doing is I'll say, what is RMS at R1? What is peak at R2? What is peak to peak at R3? And those are the answers you're going to have to give. So, and this drill right here is aimed right at the college students or at my more advanced high school students if they're doing the AC side of things. Because when you're dealing with, you're never going to, everything I've read, everything I've ever looked at, you're never really ever going to get peak. Trying to figure out the peak voltage is, you get an RMS reading, you'll figure out your peak by doing the conversion. Average is used for something else, and I can't remember because in the field I have never used anything but RMS. But that doesn't mean it does not have an application somewhere else in the electrical field. There are very few people who have experienced the full breadth of the electrical field, but all of us need to know the basics to the electrical field if we're going to call ourselves electricians or journey persons. If you're just going to be a part swapper, don't worry about this. You don't need it. If you're just going to go out and swap parts and you're not going to go into the technical side of it, just don't worry about this. Just go be a part swapper. If you're going to call yourself a tradesperson, especially as an electrician, you need to know this. HVAC techs need to know a little bit about this. Actually, they need to know a whole lot as we go further into it because they deal with capacitors on a daily. Elevator guys. I don't even know what to call the elevator guys. One of the best jobs in the world to get. I didn't know about when I started. Anybody who does anything electrical who's not just going to be a part swapper, installer, who really wants to be a technician, journey person, or whatever the titles are, wherever they work, they need to know this theory. For one thing, it makes them better educated in the field. And they understand. I understand a lot more. So if somehow I got a part and it came in, it gave me the average voltage, which I have no idea if it comes like that because I've never seen it like that, but I haven't worked in the full, there's no way I could have worked in the full scope of the industry. If it does that, then I know how to get to RMS, what my meter should read. But that's what this is for. And circuit analysis like this, swapping back and forth and doing and checking, is as close on paper as we're going to get to troubleshooting. Now, as I go on and I do a few more of these, I'll be putting switches in and showing how to check on switches, basic switches. I'm not going to go hardcore and do a bunch of PLC work, or PLC is the only thing I can think of off the top of my head right now. But I'll do some basic switching, so you have to pay attention to what's on, what's off, how it affects the circuit, what your reading should be, because that's important when we get down to troubleshooting. And if we're just going to swap parts out, we really don't need to be that. It's not that big of a deal. But if we're really going to find the problem and not just swap parts out or go to a bigger fuse, I do not like that theory of things. That means whatever was wrong was not fixed. You just put the bigger fuse in until whatever is wrong burns all the way out. But being able to do these things, be able to do the math, you don't have to be a genius at math, but you have to understand what math you're looking for, what you need to do, and what it needs to look like. Nothing more. I check books. I always have a book. Where's my freaking uglies? So as I have uglies or something around to help me. And if it's not my uglies, this book I have around if I need to look it up. I write notes in my code book. I don't have my code book is out in the truck. But in my code book, I write notes. I don't have to memorize all these things. And for the most part, and when I was in my apprenticeship, I'd memorize it enough to get through a test and data dump. And then write it down so I had it if I needed it. But being able to do this is just one of the skills of being a journey person. That's flat out it. Okay. That's me. I'll get off my soapbox now. Everybody